Joining us for today's webinar, Driving Towards Sustainable Water Management, Challenges and Strategies for Water Utilities. I'm Leslie Bebko, your host from Water Online and Life Science Connect. With me today, I have Sheila Key and Brent Koffenberger, Senior Project Managers from Itron. Over the next 45 minutes, Sheila will be discussing water distribution, metering, usage, and leakage, and how to reduce non-revenue water loss with leakage detection and analytics, enhance operational efficiency, I can't talk today, and drive water conservation. After her presentation, Brett will be joining us for a live Q&A session. Feel free to submit questions as we go along. We'll get to as many of those as possible during the Q&A. Any that we can't get to, we'll follow up on after the event. If you run into any issues, please try refreshing your browser first. If you need additional support, let me know via the Q&A. I'll get you back on track. Finally, this webinar will be available for on-demand viewing. You'll receive a link via email as soon as that's available. With all of that said, I'm going to turn it over to Sheila to get us started. Sheila?
Thank you, Leslie, for the introduction. A very good day, everyone, and it is a pleasure to be given the opportunity to present to you on the topic of driving towards sustainable water management. Before we begin, let me give a quick introduction about Itron. Itron is a leader in the management of energy, water, and the industrial Internet of Things. We have more than 8,000 customers in 100 countries. We've delivered more than 200 million communication modules globally, 4 million streetlights managed by Itron Tech. We have over 5,000 employees, and we work with over 250 partners in our ecosystem, developing solutions to solve challenges and to enrich the value of our portfolio. We have revenues of $1.8 billion in 2022. So let's begin. So for the agenda today, we'll talk a little bit about non-revenue water as it relates to sustainable water management, look at the causes of non-revenue water, why we should address non-revenue water, and what are some of the strategies we can use to mitigate non-revenue water. We'll look at setting and achieving, monitoring and evaluating your non-revenue water targets and efforts, look at the benefits of addressing non-revenue water, and lastly, we will just go through a quick overview of Itron's thermometer analysis solution for non-revenue water and how it can help water utilities. Water utilities around the globe face a variety of challenges in providing reliable, safe, and affordable water services to their customers. Common challenges, as we all know, are aging infrastructure, water scarcity, meeting regulatory compliance, non-revenue water. Sustainable water management is critical in managing your water network to ensure effective and responsible use of water resources in a way that meets the needs of present and future generations. So let's take a look at non-revenue water and sustainable water management. Non-revenue water does represent a significant challenge to sustainable water management. In terms of economic sustainability, we know that high levels of non-revenue water results in financial losses for water utilities. These losses can affect the water utilities' ability to maintain and to upgrade infrastructure, invest in water quality improvements, and expand services to meet the growing demands. And then in looking at resource efficiency, we all know that water is a finite resource. So when a significant portion is lost through leaks, unauthorized consumption, and other reasons, it places a high stress on the available water supply. Sustainable water management would aim to use water efficiently and to minimize waste. And then in terms of environmental sustainability, non-revenue water does have a negative impact on environmental impacts. Like, for example, you have leaks in water distribution system that can lead to soil erosion, damage to infrastructure, and contamination of groundwater. Sustainable water management would look at minimizing these environmental impacts. And then you have social equity. High non-revenue water can result in disparities in access to clean and safe water. Some areas may experience water shortages or poor water quality due to water losses, while others have better access. So sustainable water management will seek to ensure we have equitable access of water to all communities. So as we all know, water is a very energy-intensive industry. We pay for the energy to pump, to treat, and to distribute water. The EPA estimates that for most water utilities, 40% of the electrical usage is used for their water treatment plant. So essentially, water that gets produced and doesn't get used does contribute to greenhouse gas emission. It takes a lot of energy to pump water, to maintain pressure in the system, and to treat water when it comes back from the sewage system. Water taps into the electricity grid like nobody else does. So reducing non-revenue water will have a positive impact on climate change through your greenhouse gas emission reduction. So let's take a quick look at the causes for non-revenue water. So here, non-revenue water is the portion of water that is treated and distributed water that is lost within your water distribution system before reaching the end consumer. So non-revenue water comprises of all forms of water losses that occurs throughout your water supply chain, from your water treatment plant to your customer's tap. So these losses can be broadly categorized into real losses or apparent losses. Real losses really represents the potable water that never reaches the consumer. It is basically looking at the recovered volume and cost that is based on the production cost of water, whereas apparent losses represents your potable water reaching the consumer but never billed. So this is recovered revenue that is really based on the selling price of water. Most utilities don't really know the exact split between apparent losses and real losses. According to the International Water Association, the IWA, real losses typically made up about 2/3 of water losses and apparent losses 1/3. So the causes of non-revenue water can be categorized into 3 different categories: physical losses, commercial losses, and unavoidable losses. So let's take a quick look at each of them. So real losses represents your physical water loss from the distribution system, really leaks, bursts, and other physical failures in the infrastructure. These losses occur within the network itself and are often a result of aging or poorly maintained infrastructure. You have pipe leaks and bursts, aging pipelines, corrosions, and change of any above ground infrastructure or lack of maintenance can lead to leaks and pipe bursts. These failures often result in significant water losses as water escapes from the distribution system. And then you have leaking valves and fittings. So faulty or poorly maintained valves and fittings can also contribute to real losses. These components are, if you think about it, these components are really critical for controlling the flow of water within the system. So their failure can lead to water leakage, overflow from reservoirs and tanks. In some cases, water reservoirs and tanks may overflow due to malfunctioning float valves or excessive pressure. So this overflow can also represent a form of real losses. And then you have your leakages in your secondary network. So this goes beyond the primary distribution system. You're looking at leakages such as service lines to individual properties and smaller diameter pipes. These small leaks can collectively contribute to significant losses as well. Let's move on to apparent losses. So apparent or commercial losses are associated with inaccuracy of metering, theft, and unauthorized consumption. These losses can occur at a point of billing and distribution to the consumer. So metering inaccuracies, you have faulty, incorrectly calibrated meter can lead to underreporting or overreporting of water consumption. This results in discrepancies between the amount of water that is supplied and the amount billed. Meter tampering, some consumers may tamper with their water meters to try to reduce their recorded consumption, leading to underbilling and ultimately revenue loss for the utility. Illegal connections, you have unauthorized or illegal connections to the distribution system, and this will cause water consumption that goes unaccounted for and unbilled. And then water theft, really deliberate theft of water, such as tapping into the distribution lines without permission, is a direct form of apparent loss. And avoidable losses, these are losses that are considered to be a normal part of your distribution system's operations, and it is very challenging to prevent it entirely. These losses are essential for maintaining system reliability and safety. So firefighting, water used for firefighting purposes, such as including hydrant testing, firefighting activities, these are examples of unavoidable loss. Ensuring an adequate supply of water for emergencies like that is critical. And then you have system flushing and maintenance, flushing of the distribution system to remove any sediments, to ensure a certain level of water quality, as well as maintenance activities like valve exercisings and repair. This can also lead to temporary water losses. And then, as we all know, there is a requirement for a certain amount of water to maintain system pressure, especially in larger distribution networks. So the water serves to prevent backflows and contaminations, and it does contribute to your unavoidable losses as well. So next, you will see this is the International Water Association, or the American Water and Wastewater Association water balance table that really is used to describe and break down the key features of managing and understanding what a typical water distribution system is, either at a territory level or a district metered area level, DMA level. So it starts off with your system input volume, which is water entering the system, and it breaks into two sections: authorized consumption and water losses. Or the other way of classifying it is looking at revenue water and non-revenue water. So you can see where the causes of non-revenue water lies within the water balance table. At this point, I am going to pass it back to Leslie, where she will conduct a poll questions. Leslie?
All right, thanks, Sheila. Great information there, and we're going to ask you some questions now. So just to get an idea of where all of you are in your journey, what is your estimated water loss? So on your screen right now, you should have a pop-up. Let us know, what is your estimated water loss? Is it between 0 and 10, 11 and 20, 21 and 30, 31 and 40, over 41%, or you don't know? And please take a moment, answer that. And we do have two others after this, so I want to try to get to these as quickly as possible. We're going to do them all in a row. If you have a chance. All right, just a few seconds. And I'm not overly familiar with water loss. Normally I would speculate on these, but I have no idea where this is even going. So not sure. All right, we're gonna go just a few seconds here. All right, so in here, just real quick, Sheila, if you want to take note of those, it looks like, and there's a decent amount that don't know, but then it's pretty well spread out there. Okay, so just not to take up too much time, we're going to move on. Does your water utility approach water losses using real and apparent losses concepts? So your answers for that are yes, no, but we're moving in this direction, know, or don't know. So again, just going to give you a few seconds here. Looking for your input on this. Always good to know where everyone else stands. Just a few more seconds here. I'm going to hope that everybody, or well, not everyone, but that the majority are saying yes, or no, but we're moving in this direction. A few more seconds to answer. Oh, all right, great. So we do have 43.8% with the yes. And if anyone's watching this on demand later, these numbers do reflect the live audience results. So you may be seeing something different for this because the results would reflect with on demand as well, a different number. And then for our final question here, are you facing additional regulatory requirements with regard to reducing water losses? So yes, no, or don't know. So this one's a quicker one to answer, and then we'll get back to Sheila's presentation. So are you facing additional regulatory requirements? All right, I'm going to push this pretty quick so we can get back to you, Sheila. And, oh, all right, just about split. So, all right, well, thank you, everyone. And again, just real quick, if you haven't had your chance, submit questions for Sheila for the end, and I'll see you again soon. Back to you, Sheila. Thanks.
Thanks, everyone. So this is really interesting. So going back to what is your estimated water loss globally in the world, non-revenue water it averages around 30%. So I think based on the poll results and that we see about 14% stands around the 30% range. And I would say because this is North America audience, right? So we do have better managed systems around here. So like almost 45% are below the 20% mark, which is what I was kind of expecting. And then as we can tell, more water utilities are looking at water losses because water is a finite resource. So it is good to hear that about 43.8% are actually using concepts on looking at real and apparent losses, because when it comes to dealing with non-revenue water losses, in order for you to fix the problem, you really need to know what are the causes of non-revenue water. Is it real? Is it apparent? And then there's different strategies and actions that you can take to resolve those. And in terms of regulatory compliance, I think it is a split. We are seeing more regulatory requirements around water losses. So, and I think based on the poll results, 42.1% said yes, 42.1% said no, and the rest, they weren't sure. So let's go back to the presentation. Thanks everybody for completing the poll results. And so we'll move back to the presentation. So why address non-revenue water? The consequence of a utility to ignore or to put off addressing non-revenue water will have impacts not just on the water utility, but the communities and the surrounding environment as well. So in terms of financial implications, we know that there is revenue loss for water utilities. Water that is lost and not built represents a direct financial setback. It also makes it really challenging for utilities to cover operational costs and to invest in system improvements while they're trying to fix and be very reactive to existing problems. Increased operational costs. Utilities must expend additional resources to treat, pump, and distribute water that is ultimately lost. So this is kind of waste. It leads to higher operational costs, further straining budgets for a utility to take on any other water improvement projects. And then reduce investment capacity. You have high non-revenue water losses really limits the utilities' capacity to invest in infrastructure upgrades and maintenance, potentially compromising the reliability and efficiency of your water distribution system. And then in order to prevent more financial or revenue losses, utilities may have to look at increasing water tariffs, which will eventually place an economic burden on your consumers, especially your low-income household. And then environmental impact, like wasteful resource use, right? The loss of treated water represents wasteful use of this finite and essential resource. We can live without electricity, but nobody can live without water. So as water scarcity becomes a global concern, conserving water is crucial to environmental sustainability. And then you have energy consumption. As we mentioned before, there is a lot of energy that is used in treating and pumping water that is ultimately lost. So this contributes to higher energy consumption and carbon emissions, impacting the carbon footprint of a water supply system. And then ecological impact, when there is high non-revenue water losses, this could lead to over extraction of water from existing natural resources to compensate for non-revenue water. So this can have adverse ecological effects such as reduced river flows and habitat disruption. And then in terms of social and community consequences, right? When you have high non-revenue water, it results in maybe unreliable water supply, leading to frequent service disruptions, inconveniencing consumers, and affecting their quality of life. And then when it comes to affordability, when utilities have to compensate for water losses by raising water tariffs, then it makes water less affordable for lower income household, increasing the issues of water equity and access. And then the other important thing is, why we need to address non-revenue water goes back to health and hygiene. When you have inadequate water supply due to non-revenue water, it can compromise public health, such as access to safe drinking water and sanitation services. So these are all critical in terms of, having good hygiene and disease prevention. So let's take a look at, what are some of the strategies we can use to mitigate non-revenue water. So the really first step to understand your non-revenue water is to conduct a water audit. This is the first step in understanding the performance and the inefficiencies that is associated with the water distribution system. The water audit can provide valuable insights into how water is managed and to help identify areas where improvements are needed in terms of water conservation, improving operational efficiency, and cost savings. And before you do the water audit, you do want to define the area that the water audit will cover. So you're going to get data from various sources such as your water treatment plant, pump stations, to your individual consumption data. And these data will be collected and time synchronized and normalized for any time variations between the collection period, so that eventually you will get a water audit that tells you how your system is performing. So a continuous water audit or water balance is really essential for utilities to identify problem areas, to allocate your resources and budget efficiently, and then to implement the right targeted strategies to reduce non-revenue water. So some of these strategies can include infrastructure improvement, technology improvement, looking at metering, metrology, human resource and training, and regulatory measures. So let's take a look at each of them more in depth. So infrastructure improvement. So we know pipeline rehabilitation and replacement. This is really one of the strategies to deploy to mitigate your non-revenue water loss, is to make sure you have a program for pipeline rehabilitation and replacement. You want to be able to identify and replace aging or deteriorating pipes to reduce your physical losses caused by leaks and bursts. Valve and pump optimization. You want to ensure that valves and pumps are well maintained and operate optimally to minimize water losses. And then implementing district meter areas, DMAs. So DMAs really involve dividing your distribution system, breaking it from a bigger system into smaller, more manageable zones so that each one of them is equipped with flow meters and isolation valves. So this will allow you as the utility to monitor and isolate sections of the network, making it easier to know where to go, where to fix your problems, where the leaks are happening, and to manage your non-revenue water more effectively. And then technology adoption. You can implement AMI, advanced metering infrastructure systems, to provide accurate real-time data on water consumption. And then you can encourage water conservation. This will improve your revenue collection and enable utility to detect anomalies promptly and to reduce non-revenue water. The other strategy to deploy is looking at pressure management. Optimizing pressure within the distribution system can help to reduce likelihood of leaks and bursts. Pressure management systems can adjust pressure levels, such as based on your demand, trying to minimize the stress on your pipes. And then leak detection technologies. There are various technologies such as acoustic sensors that can detect the sound of water escaping from pipes, aiding in the quick and prompt identification of leaks as and when they occur and the severity of those leaks. And then there is additional things like monitoring and control systems, making use of technology to remotely monitor and control water distribution systems to allow for quick responses to leaks or any type of abnormal consumption patterns. Deploying flow meters to measure the flow of water in various parts of the distribution system. They can provide real-time data on water consumption and to detect anomalies as and when they happen, which could indicate leaks or theft. And then you have data analytics. Advanced data analytics, can help analyze flow data, consumption pattern, look at your pressure levels to detect areas with potential leaks or high non-revenue water. So this can help in the proactive management of non-revenue water. And then water meter types, metering metrology is another type of strategy you can use to mitigate non-revenue water. So part of it is, making sure you have water meters that come in various types with different measurement technologies. Each type obviously is going to have their own advantages and limitations. And as a water utility, the selection of the appropriate meter type is going to depend on factors such as flow rate, water quality, and your budget. And then making sure, whatever meters are being chosen, like you are looking at meters that vary in size to accommodate the different flow rates. Choose the right meter for the right application that will provide accurate measurement. And then you also want to ensure you have proper installation conditions for specific meters to make sure if there is straight or horizontal pipe requirements before or after the meters, those are done correctly at the point of installation to prevent any type of turbulence or inaccuracies in measurement. And then you have metrological performance. So water meter accuracy is critical in revenue collection and also in non-revenue water reduction. So meters should be chosen based on their accuracy and ratio specifications. We want to make sure we have regular maintenance and calibration, that these meters continue to perform within the acceptable limits. And then as we all know, over time, water meters may experience wear and tear, leading to decreased accuracy. So understanding the aging curves of meters can help in predicting when meters need to be replaced or recalibrated to maintain accuracy. And then you have, reading and handling mistakes, right? We know if you are reading your meters manually, there is always human errors that can contribute to non-revenue water in terms of apparent losses. Mistakes can occur when you have incorrectly meter reading that are incorrectly recorded or misreads that require estimation. So moving towards some kind of automated meter reading, in addition to proper training and quality control measures, will help to reduce these reading data errors. And the next strategy is really looking at human resource and training. Some water utilities don't have in-house capability to have leak detection teams or data analysts and engineers on their team, but you can always work with vendors who has subject matter expertise, who has the ability to provide such expertise to help you manage your water distribution system. So you want to make sure you assemble a dedicated team that is trained in leak detection techniques and equipped with tools to help identify and to repair leaks efficiently. And then data analysts and engineers, you want to have professionals who can analyze the data, assess the system performance, and to develop appropriate strategies for non-revenue water reduction. And then in terms of regulatory measures, we all know that when you implement pricing, certain pricing structure, it can help to encourage water conservation and reduce wasteful consumption. So this is really important, and one of the strategies utilities can implement to help with non-revenue water management. And then obviously, you want to make sure there is legal actions against water theft. Enforcement of legal measures is critical, because you want to make sure if there is any type of non-compliance or illegal actions taken place, fines are appropriately assigned so that it will discourage future behavior of such kind. So after we've talked about, what are the strategies, as you can see, there is a lot of strategies. Not all utilities are going to implement all of them. Pick and choose the one that works for you within your budget, within the resources that you have. And then once you decide what are the strategies you want, the other thing that we look at is, to make sure you have clear targets and well-defined strategies, right? We want to make sure you have the ability to set and achieve the non-revenue water reduction targets that you have. So, goal setting 101, make sure they are specific and measurable. These targets should allow utilities to track the progress accurately. So for example, you want to reduce non-revenue water by a certain percentage or volume over a defined time frame. And then making sure the targets are realistic and attainable based on the utilities capacity, your available resources, and the condition of your distribution system. And then making sure you set a time frame or deadline to achieving all these targets so that it provides a sense of accountability and urgency to the people who has the responsibility to meet these targets. And then we also know that once you have strategies that are implemented, it is very critical to monitor and evaluate your non-revenue water results. So regular assessment, you want to continuous monitor and evaluate your non-revenue reduction efforts. So this involves collecting data on water losses, conducting regular audits or having access to regular audits, employing measurement techniques to assess what the progress is. And then ultimately, you want to have or develop, you want to have performance matrix that will track all these strategies that is being implemented. Is it going well? Is it not going well? Why is it not going well? And to have that evaluation phase that you can adjust your strategies accordingly. So develop performance indicators like your KPIs that measure the effectiveness of your new water. So the matrix could include leakage rates, meter accuracy, revenue collection rates, etc. So after talking about, setting, measuring, evaluating your non-revenue target goals, so once you have set all these, what are the benefits when, as a water utility, when it comes to addressing non-revenue water? Mitigating your non-revenue water will yield many benefits for the water utilities as well as the communities you serve. So these benefits encompasses financial, operational, environmental, and social aspect. So really making non-revenue water a critical objective for water management. So some of the benefits includes cost savings. When you reduce non-revenue water, it leads to increased revenue for the water utility. Utilities can accurately bill for water supply. This additional revenue that is collected can offset some operational costs and reduce the need for rate increase. You have increased revenue with more accurate billing. You have improved service reliability, making sure you have consistent water supply. Lower non-revenue water would mean fewer service disruptions, resulting in more reliable water supply for consumers. And then, looking at resource conservation, right? Preservation of water resources. When you address non-revenue water, it allows especially in regions where they are facing water scarcity and drought conditions, it allows improvement in the water distribution. And then with you would lower non-revenue water would mean improved service quality, reduce water wastage, and more equitable access to water services, leading to higher customer satisfaction. And then we also know that lowering non-revenue water will reduce your energy that is required for water treatment and distribution, leading to reduced greenhouse gas emission. So this will allow you to have energy savings as well. And then, addressing non-revenue water would help utilities comply to regulatory requirements, reducing the risk of any type of penalties or sanctions that could come about. And then, we want to reduce non-revenue water, really allow more people to have access to safe and reliable drinking water, improving public health and well-being. And then it can also allow for equitable water distribution, benefiting all segments of the community. And I think ultimately, by minimizing your water losses and optimizing distribution system, utilities become more resilient to climate-related challenges such as drought or any type of extreme weather events that could take place. So how can Itron help for non-revenue water monitoring and reduction? So we have a solution called Itron's Thermometer analysis. I will go through that in a bit. So using Itron's water end-to-end solution, from meters, AMI data, thermometer analysis, to help provide an understanding of your non-revenue water footprint. Basically, what the software is going to allow you to do is identify what the problem is, where is it happening, when is it happening, why is it happening, and what actions should I take to overcome the problem. So here you will see the entirety of the thermometer analysis offering that is really focused on water loss management, in terms of there's 3 core modules: operational visibility, water revenue assurance, and water management. This is really looking at integration to a single type platform. Your data sources can come from AMI, GIS, sensor data such as pressure and hydraulic models. The integration provides that comprehensive view of the distribution network that will aid in effective non-revenue water reduction at a territory-wide level, pressure zone, or DMA, district meter area level. The key to the software offering is it provides that automated water balance. So if you're collecting monthly reads, you can have a monthly water balance at your fingertips. If you're collecting daily reads, you get daily water balance. And if you have AMI systems, you can have hourly water balance. So really eliminating the manual process of gathering data from disparate systems. And in addition, the key to this is it will actually give you a split between your real and apparent losses, both at a territory level and at a district meter area level. So you can look at where your systems are not performing as well. It's basically going to tell you where not to do and where not to take action and where to take action within your distribution system. It also allows for water loss KPI monitoring, which really utilities can establish the KPIs such as your infrastructure leakage index, ILI, looking at your CARL, your current annual real losses, your unavoidable annual real losses, your apparent losses, real losses, to monitor and to be informed of any deteriorations or improvements to those metrics, allowing you to take corrective actions and timely actions when needed. So the other thing is it can also assist utilities in meeting your regulatory requirements when it comes to non-revenue water reduction by providing accurate records of your water consumption and losses. And then AMI systems, provide continuous near real-time data on consumption within the territory or district meter area. So this data can really help utilities to keep a close eye on water flow and pressure, allowing for quick detection of leaks and anomalies within the area. There is also the ability to provide visualization of hourly flow and pressure and tank levels, as well as 48 hours of forecasting. We can do hydraulic simulation and visualization and transmission means monitoring as well. And then identifying anomalies such as any type of unusual consumption patterns that may indicate meter inaccuracy, illegal connections, and unauthorized consumption. So this will help to address apparent losses more effectively. And then by analyzing AMI data together with hydraulic models, utilities can also locate leaks, the areas where leaks could be occurring. So this precision will help prioritize repairs and minimize your water losses. And then you have water revenue assurance, which really it does the analysis of your current meter population and allows the utility to identify what are the optimal meters to be replaced to generate the best return on investment. So basically, this is a platform that will bring information from disparate systems together to provide visibility to the health of the distribution network, as well as to identify areas where additional assessment or actions are required. So if you look at this thermometric analysis in the view of a water balance, operational visibility really gives you that true understanding of what is happening, the composition of your distribution network. It has all the components of the water balance, including the split between real and apparent losses. And then you have water revenue assurance, which is really aimed to tackle apparent losses and water leak management for real losses. So here you see kind of a flow chart. You start off with operational visibility that provides the health of your distribution system. It provides insights into what is causing your non-revenue water losses. At any one time, you could get a spike in real or apparent losses. So you, as the utility, would take necessary actions to investigate where the problem is and to resolve the issues. So through all these targeted actions, it should bring about an improvement in your water key performance indicators over time and essentially bring your non-revenue water to the target level. So really helping you to get to that stage of having a well-maintained system, which then will reap a lot of the benefits such as financial savings, increased revenue, improved infrastructure, conservation of your resource, environmental benefits, and enhanced customer satisfaction. So the key takeaway here is We all know that the water distribution system is a dynamic network. It is not static. Fixing leaks in one area doesn't mean that other leaks are not going to surface. So we require continuous monitoring to provide you with the constant vigilance that is required in your water distribution network, giving you the ability to take prompt targeted actions and to resolve issues as they surface. So here it's just showing you a couple of screenshots that we have in the solution. It provides you a map view of your monitored area, the hourly water balance that splits into real and apparent losses. And in conclusion, so the path to sustainable water supply, right? We all know achieving your non-revenue water target is really the key step to ensuring a sustainable and reliable water supply for communities. Itron's water end-to-end solutions can play a critical role in helping you optimize your operations, improve efficiencies, and reduce non-revenue water and enhance the overall performance of your water system. This will lead to cost savings, better service for customers, and a more sustainable water supply network. So the call to action that I have for water utilities is, take proactive measures to address non-revenue water. Prioritizing non-revenue water reduction is not only responsible, but it is also a strategic investment in the future of water supply systems for the current generation and the future generation. And with this, I end my presentation and I'll pass it back to Leslie.
All right, Sheila, thank you so much. So we've gotten a lot of requests for the slide deck, and to me that just means that it was, when I've gotten those requests before, it means that it was such a great presentation that people want to share it for educational purposes. So for everyone who has requested that, I don't have the deck in a shareable format. We have it just to have distributed on the platform. So if you can reach out to Sheila or Brett directly in your request for that, their contact info is on your screen right now. You can reach out to them directly. If you can make those requests, they should have those in a format that would be suitable for email. So just wanted to start off with all of that. And if you haven't had a chance to submit your questions, please do so now. Other than those requests, we have a couple of others. So give me a second and let me jump down to that screen. So Brett is going to be joining us for the Q&A. So between Sheila and Brett, how can water or combo utilities and local governments work together to adopt new technologies like non-revenue water management and AMI?
Yeah, that is a great question. I think, it is very important for water utilities and governments to collaborate to tackle non-revenue water by implementing very coordinated strategies and initiatives, right? Water utilities can provide local governments with data on what is happening in their non-revenue water levels and what are the causes, and local government can actually use the information to help promote and to identify priority of areas for action. And then, I think local government too can allocate funding and provide grants and incentives to support non-revenue water reduction projects and definitely infrastructure improvements. And then I think, when it comes to working together, right, you want to prioritize your investment. You want to target. Local governments can look at what are the areas that are suffering from like high non-revenue water losses, and then to help support utilities in securing financing for these projects. Brett, did you have anything else to add to that?
Sorry, Sheila. No, I think you hit it right on the head.
All right, thanks, Brett and Sheila. Always good for collaboration when everybody works together. So moving on, how can technologies such as leak detection systems and smart meters help in managing and reducing non-revenue water?
Yeah, another great question. I think when it comes to using technology, it really empowers water utilities to proactively manage and to reduce non-revenue water, especially when you have smart metering systems that can provide real-time data on water consumption. It allows the utilities to detect your anomalies and irregularities quicker that could indicate any type of leak or unauthorized water usage. Um, and then I think with early leak detection, right? Like if leak detection technologies are deployed using sensors or any type of monitoring device, it helps to identify leaks quicker. So with early prevention, you are preventing um, prolonged water losses and associated costs that comes with the prolonged water loss. So having that ability to quickly look at, what are the leaks that you have within your distribution system in terms of severity, and prioritizing where leaks should be fixed. I think this technology that utilities should implement to help reduce and manage their non-revenue water losses.
All right, great, thank you. Let's see here. What should be the specific targets and goals for reducing non-revenue water in our water management plan?
This is a really good question. I think when it comes to specific targets and goals, it is going to be very unique, right, or tailored to individual water utilities, depending on, because you're all going to have different types of challenges. But I think in general, there are examples of targets and goals that can be incorporated, such as looking at what is the reduction percentage you want to achieve, right? You want to set a target percentage over a defined time frame. So maybe reduce non-revenue water losses by 10% within the next 5 years. And then you have the strategies that you want to implement to do those. Or, you could have a goal for early leak detection. So saying things like setting the targets like locating and addressing 90% of your significant leak within a 48-hour detection period. You can set targets on, infrastructure upgrades and replacement to reduce your physical losses, right? Know which are your high risk pipes that should be due for replacement and budget it accordingly throughout the year. Looking at meter accuracy as well, you could ensure that you're always making sure that your existing meter population is regularly calibrated and maintained, because this really impacts your billing accuracies. Yeah, I think those are things that utilities can incorporate as their goals, and obviously, again, it's going to be back to what are the current pain points for the existing water utility and what is the problem they're trying to solve, and then set the appropriate goals and targets with respect to that as it comes to reducing non-revenue water loss.
All right, yeah, that makes sense, absolutely. Do you need an AMI network to effectively manage non-revenue water?
I'm going to pass this to Brett.
Sure. So I think the key term there is effectively. So do you have to have AMI? You don't have to have AMI to improve your non-revenue water loss. Simply doing a meter change out to new meters is obviously going to improve accuracy and take care of some of that by itself. So, but I think the key is effectively. So, when you have AMI, you're getting frequent data. You're getting frequent alarms, frequent data, so you can identify continuous flow. You can isolate things in the network. Everything's visible on a dashboard where you can quickly go out and address problem areas or areas of concern where you may have your continuous flows, things of that nature. So I would say that, the key term there is effectively, but definitely AMI is going to drastically improve your ability to manage that.
Okay. All right. Thanks, Brett. So to both of you, if you could please take a look in the inbox for the questions that are in here. I think we have a few that are going to have to be answered offline, either because of clarification needs or because they're going to take too long to answer in the time that we have left. Let's see. I think Howard's, we can get to that one. Do you have leak detection AMI meters? That one should be easy enough to answer here.
Brett, did you want to answer that?
Yeah, I could take that. So there's a couple different ways to, when you say leak detection, there's acoustic leak sensoring, and then there's leak detection in the meter in the system. So you're getting a very finite, accurate meter read. Acoustic is obviously listening to acoustic anomalies in the pipe. So we have a separate device called our OLS leak sensor that actually connects to the pipe and actually listens for those anomalies. It's not internal in the meter. However, you can actually change that out without changing the meter out should there be a failure or something to that. So it's really preference and cost versus what you're going to get back. So we do have a solution for that, which we could provide more information on.
All right, thanks, Brett. Do see another few questions in here, but I think we're going to have to answer those offline, unless you guys tell me differently. I think with that, we're going to wrap. Thank you so much for such a great presentation and for your help, Brett, with the Q&A. But Sheila, thank you so much. And oh, do we have some? No? Okay. Thank you guys so much. Great presentation. Sorry. To everyone who joined us today, if you submitted a question, we didn't get to it, we will reach out to you directly afterwards to get back. Submit any other questions you have, make those requests directly to the presenters, and look forward to seeing you again real soon. Have a great rest of your day.